So the ping starts with a ping request. The process creates the ICMP echo request. The source IP is not specified. Okay. So the device sets it to the port's IP address. The device sets the TTL. The destination IP is not in the same subnet. Okay. So
Right.
we know that. And the default gateway is set. The device sets the next hop to the default gateway. Next layer. But when it gets down to the link layer, the data link layer, what happens to the ICMP request?
When it gets to the data link layer, they attempted to forward the packet. They attempted to forward it. They send it over to the switch and sees that the source destination, that the source port is not in the table.
Well, it appears that it is in the table.
It is in the table.
Hold on. Let me look at this again. This is PC1. Yeah, and it's got the router in the table. It should not have the router in the table.
Yeah.
There we go. Let's kill this. Let's restart it. There we go. That's better. Okay, so we have ICMP, and then we have ARP, and ARP now says, okay, it's not in the table. So it's going to send out a, if it doesn't have the table, what is it going to do with it?
It's going to send a broadcast address from this. It's going to forward it to router A. The gateway
Towards router A, correct. And how do we know that it's going to do a broadcast?
Because nothing is in the table. Because the source address is not in the table. Because the destination source address is not in the table.
We're not looking for the source address. We're looking for the destination address, right?
Because the destination address is not in the table.
Okay. And take a look at the destination MAC here on the screen. What do we fill it with?
RF.
Very good, which means broadcast.
It means it broadcasts to PC0 except where it came from.
Right. So the next step is this ARP request is going to go to the switch. And what's the switch do with that frame as soon as it gets it?
It checks to see if the destination address is in there. If not, it sends a broadcast address to PC0 and router A.
Remember, what does a switch do with a frame when it receives it? The first thing it does.
And then the PC1 says, frame contains ARP request to switch 0. And it reframes the frame containing the ARP request. It opens it up and then it examines the frame contents to look up the source MAC address. And when the source MAC address is in there, it adds it. And when it's not in the switch table, it adds it in there.
Okay. So it's going to look at the source address, the source MAC address, and if it needs to, it's going to update the table.
Right.
Like we see here, right?
Right.
All right. So let's let it do that. Let's watch it do that. It sends it up there. And then when we go to look at the MAC table or the switch, show MAC, We see it's in there. Okay.
Yeah.
Now, notice what else is in there.
It is the source MAC address of 82.68 or PC1.
Right. But what else is in there?
It's also the router.
So the router. Okay. Very good. All right. Now that the switch has this packet, what's it going to do with the packet?
It's going to broadcast it to PC0 and router A.
All right. Let's let it do it. And router A or PC0 is going to do what?
PC0 is going to drop because it's not for me.
Right. And router A is going to do what?
Router A is going to check to see if it's for them.
And they're going to find out that it is, correct?
And they're going to find out that it is.
Okay. Then what we need to do is, what's router A going to do next?
Then router A is going to check to see if the destination MAC address is in the table.
Okay.
So it's not.
Yeah, but remember, this is an ARP request, so it's got to respond to the ARP request, right?
Right.
So that's the next thing that it's going to do. And see it going back?
Keep going back from here.
Goes back from the router back to the switch.
It goes back from FA0 to FA24.
Correct. And the switch is going to get it. What's it going to do when it receives that frame?
When it receives that frame, it's going to open it up.
And what does it look at first?
It looks at the source MAC address to see if it's in the table. Very
good. And is it already in the table?
We did. Yes.
It is. Yes, it is. So that's done. Now what's it going to do with this frame?
Then it's going to send it out. After it goes back to the switch and sees that the source MAC address is in the table, then it's going to send it out from a router to the. Then it sends it out to the router.
Or sends it to the router, or we're coming from the router.
Coming from the router. Give me 1 second.
Yeah, go ahead.
Hey, Jim. Sorry about
Hey, Sam. No problem.
Then it sends it back to the router.
No. Wait a minute. Doesn't send it back. We're coming from the router, right? We're going from the router and we're headed towards PC1, right?
Right.
Okay. So the switch has the packet now, and it looks for the destination MAC address. Does it find the destination MAC address in its table?
For router A?
No. For the packet here. If I've got the packet, okay, does it have, if you look,
Yeah.
you see what the destination MAC address is that MAC address in the switch table?
Yes.
Yes, it is. Okay, and we can see it right here. Okay.
Right.
So we say next, and is it going to do a broadcast or is it going to be go directly to PC1?
It's going to go directly to PC1.
Yes, it is. There it goes. And now here comes the ICMP ping. It goes up. Again, switch is going to do what to that frame?
The switch is going to forward it to the switch is going to open it up. Switch is going to the switch has the destination.
No, the switch first it looks at the source address.
And it's in there.
And if it's in there, then fine. Otherwise, it's got to update it.
Right.
Right?
Right.
Okay.
So
Go ahead.
So if it's in there, it doesn't do anything. But if not, it will update.
Right, and we know it's already in there, so it doesn't need to do an update. So what's it going to do next?
It's going to forward it to router A.
Okay, well, it's going to basically look at the destination. It's going to say, do I have the destination address? If I do, then I'm just going to forward it out that port. And what port is it going to forward out?
It's going to forward it out from FA024.
Correct. Okay, so we're going to let it do that. There it goes. And so it sends it directly. It sends it directly to router A. Router A picks it up and says, yep, this belongs to me, but it needs to, now what does it need to do? Because where is this ICMP ping going?
It's going to be going to switch 1. But
ultimately, yeah, or yes, it's going to go to switch 1, but ultimately it's going to go to PC3, right?
PC3.
Yeah, so let's take a look inside this thing. Okay. And we see that as it comes in, okay, it's headed for router A, which it hits, but its ultimate destination is 192.168.20.13. However, when it goes to send it out port F01, what is it going to find?
It's going to, for FA01, it's going to find.
It's going to find, actually, I'm looking at it, and it found the MAC address for PC3. And that should not have been the case. Okay, let's see. Enable, show MAC. Okay, the MAC is not there. Let's show ARP. Yeah, it's in there. It's already in there. So it knows where it's going, and it's going to allow it to go there. So let's let it go. The switch gets it, looks at the source MAC address, and updates the table appropriately. And then it's going to forward it out to FA02.
And FA...
down to PC3. PC3 is then going to respond. It's going to come back. And then it's going to send down to router 1. Router 1 is then going to turn around and send it back to switch 0.
And then it sends it back to PC1.
Correct. And at that point, we're done. Okay?
So if for the first time it sends it, it doesn't have the destination address in the table.
Correct.
So PC0 first sends it out, does an ICM ping to PC3, and it's not in the local network.
Yeah.
So PC1 goes directly to router A, goes to switch 0, and nothing is in there for the destination MAC address. So it does a broadcast to the router, to router A and to PC0. PC0 says it's not for me, and it drops it. And if router A doesn't have the source MAC address, it adds it right into the table.
Right.
And then if router A adds it in the source MAC address table, then it checks to see if the destination MAC address is in the table. So the destination MAC address would be 10.1.
Correct.
And D101. And then after it has it in there, then it goes back to this way and checks to see if the destination MAC address is in there. Check to see if the source of MAC address is in there. If it's in there, there's no update necessary.
Good.
Then it goes back to the router.
Correct.
Then it goes to PC1.
Sounds like you've got it. How do you feel?
Can we do like one more practice where like just with the router?
Just with the router?
Yeah, just with the router.
Okay. Yeah, I guess we can do that. All right, let's do this. Let's come out of simulation mode. Let's delete a couple of things. Okay, there you go. What do you think of that? Is that okay?
Can you get rid of the... Are we still keeping the switch?
We don't need them. I can push them out of the way.
Yeah. That one sounds
I can get.
good.
In fact, I can delete all of them if you want.
Yeah.
Is that better?
That's better.
All right, so let's try this test. And let's cycle the power on our devices so that we lose all the ARP tables. Okay, there we go. Oh, that didn't work. Hold on. Great, it's not starting.
Here it is.
Oh yeah, there we go. Okay, good. So let's just check the ARP tables and make sure that everything is out of there.
Wait.
Okay, that one is empty. Let's check PC3. Excuse me. That one's empty. I'll just check the router again. And it's only showing it's two ports, which is correct. Okay, good. All right, so now we'll do the.
And can you also do something with these, instead of making it a switch, make it that can we also replace it, like, since we're not using switch, can we also make the table with routers in there? For the one on the left side?
Okay, hold on. Here we go.
It's the one right, yeah.
Well, I actually have a router table in here. Okay.
Yeah.
So you want to get rid of these switches then?
I just wanna, can we get rid of these switches and then try and like do the router?
Okay, how's that?
That's good.
So I'm gonna let's file, save as, and we're gonna call this one example 2.
Okay.
And let's also wipe this out. Boy, that's unusual. I've never seen Notepad die. Let's reopen that. Okay, so we got that. All right, we okay, Sam?
Yeah.
Good. All right, so here we go. As you can see, we start up with an ICMP, and then what happens? The ICMP can't find what?
Can't find the destination address in the local network.
Okay, all right. Then what?
And then after that, then it checks to see if the source MAC address is in the table. Then it sends it.
Wait. It checks to see if the source MAC address is in the table?
It checks to see if, for PC1, it checks to see if the IP address and the MAC address is in the table.
Now keep in mind, we don't have any switches here, okay?
Right.
So are we going to do that?
No.
No, because we're dealing with a router, and routers don't do that. Remember, routers are primarily layer 3 or network layer devices. Although they have a layer 2 device, they primarily operate on layer 3, okay?
Right.
So, but we see here that PC1 does not have the MAC address for router A. So what does it do? It creates an
ARP table.
It creates an ARP request.
It creates an ARP request.
With what for a destination MAC address?
It creates it with all Fs.
All Fs, which means broadcast.
Broadcast.
Mm-hmm.
So router A broadcasts to PC1. Doesn't broadcast it. Nope.
No, PC1 is going to send this out, but because we took the switches out, it's only going to broadcast to one place. Where is that going to be?
PC3.
Okay, let's see. Okay. Because what is it trying to do? Right now, it's trying to figure out the MAC address for what device?
It's trying to figure out the MAC address for router A.
For router A, correct. It's trying to figure this MAC address, the D101. Okay? So it's going to send this ARP request out. Even though it's a broadcast, the only device it's going to hit is router A.
Yeah.
And we'll watch that, and there it goes. Okay, router A now accepts that, and let's take a look at what router A does with it. It receives it.
FA0.
And it comes back, and it opens up the frame, and it sees that the frame contains a destination address. Well, a broadcast address. All Fs.
All right. Right.
So it then takes apart the frame and passes the packet up to layer number 3. It sees that the frame is an ARP frame, and the ARP process processes it. The ARP frame is a request. The ARP request target IP address matches the receiving port's IP address of 192.168.10.1. So it says, great, okay, this is me. So then it's going to prepare an ARP response. The ARP processes a reply to the request with the receiving port's MAC address. So the receiving port was what on the router? What port did the router receive this packet on?
It's FA00.
FA00. Very good.
So for router A, the first one is 192.168.10.1.
Right. So what MAC address is it going to basically put in the response?
It's going to put in there, and when it receives it, it'll be 101.
No, wait a minute.
It's all F.
Yeah, D101. Okay, so it's going to send it back to D101. Okay, and we can see that. Here, look at this. You see that the source now is marked as D0101 or D101, and it's heading back to 8268, which is on PC1.
Right.
Okay. So we'll let it. And we're going to let it do that. And we'll say next. It goes back. So now PC1 receives this ARP response, and it does what with the ARP response?
It does an ICMP request back to router A.
Well, wait. Don't jump the gun. It's going to take that information. Why did it send the ARP request in the first place?
Because destination MAC address was not found in the MAC table.
So in the ARP table, so it had to go out and it had the IP address for router 1, but it did not have the MAC address for router 1 or router A.
No.
Router A. So it was trying to get the MAC address for router A. It sent the request up to router A. Router A responded to the request with its MAC address. This frame now comes back into PC1, so PC1 does what to its ARP table?
The PC1 checks to see if the destination address is in there.
No, the PC1 is going to update its ARP table.
PC1 will update the source MAC address ARP table.
So do you see that here? 192.168.10.1, and the physical address is D101, which is for router A.
Right.
Okay. Having done that, it can now continue to send out the ICMP ping. Okay. So we're going to let it do that. There it goes. There goes the ping. It reaches up to the router. Router unpackages it. The router looks at the destination IP address in the routing table and says, I've got it. It's directly connected to me. Okay. And the router sets the destination as the next hop and decrements the TTL.
Right.
It then comes down to the link layer, and the link layer says, hey, I do not have an ARP entry for PC3. I don't know what the MAC address for PC3 is. So now it's got to prepare an ARP request that's going to go out to PC3. And that's what we're seeing with the green envelope here. Okay? That's an ARP request coming out. So A is sending PC3 an ARP request and asking PC3, hey, what's your MAC table? Or what's your MAC address? Okay, so we're going to let it do that. You can see it there. Here comes the ARP request, and you'll notice that it's got all S in the destination.
All F.
Go ahead.
It's all F in there because we don't know what it is.
Correct. So we're going to let it send it. There it goes. PC3 is then going to reply to this ARP request, and it's going to put in its MAC address. Okay?
Puts in its destination MAC address.
Not so much a destination. It puts in for the source address, for the source MAC. It puts it in. Okay.
Yeah, the source MAC.
Right.
And after it puts it in, then it sends the response back to right away.
Correct.
And after that,
So what happened was the ping kind of died because it didn't know where to go, but we now have an ARP. Now if we do this again, we'll see that it will be successful, okay?
right.
So we're going to do another one. Click, click. Okay, and we're going to, here it comes. There it goes, because all the ARP has been figured out. Bang, bang. And we have a success.
Right.
Okay.
Can you also write the steps for the route, for just the routers?
Just the router?
Yeah, for one that we're doing for just the routers.
Oh, you want to go through and write all the steps for it?
Yeah,
Okay.
can you write all this?
Yeah, yeah, okay. So,
I'll be right back.
go ahead.
All right. Is it for the source or destination? For number 4.
Source or destination. What it's doing is it's trying to send the ICMP out to router or out to PC3. However, what it's saying is it realizes that PC3 is outside of our network, outside the local network of 10.0. Okay.
Wait.
So
So
go ahead.
are you look for number 4? It looks at the ARP table for the source MAC address of router A or the destination?
No. It's looking. It needs to find the address for the MAC address for router A. Okay. So I'm just trying to think how I need to say this to you. Then prepares an ARP request for the MAC address router A. Wow. Hmm. Does that make sense, Sam?
Are you meaning like there's number for the source MAC address that they can't find, or is it the destination MAC address that they can't find?
Keep in mind that what it wants to do is it wants to send this ARP request, or this, it wants to send the ping request, or the ping, over to PC3, okay?
Right.
But it realizes that PC3 is outside of the local network.
Right.
And therefore it recognizes that it needs to send the ping first to router A, but it does not have router A's MAC address.
No.
So it hasn't figured out. Ultimately, it's looking to make or figure out what the destination address is, but it doesn't have the destination address yet. It doesn't have the MAC address for router A. Okay.
Yeah, so the destination address is not in there, so it's all F's, router A, and then.
So now it's going to send it out, and it's going to be a broadcast, but because there's only one other device out there, it's going to send it directly to router A.
Then it's going to send it directly out from router A to P3.
Right.
And then PC3 looks at it and examines it.
Mm-hmm.
PC3.
Well, no. Router A gets the ARP request, and then it has to respond to the ARP request. And what is it going to respond to the ARP request? What is it going to say? The ARP request is asking for what?
The ARP request is asking for the source MAC address.
No. The ARP request is asking for router A's MAC address on port F00.
And F00.
Mm-hmm. So router A is then going to respond to this ARP request by sending the information that PC1 wants. It's going to send it back to PC1. And what information does PC1 want?
PC1 wants the destination address of.
It simply wants the MAC address for router A, port F00, which is D101. That's all it wants. Don't get caught up with source and destination at this point. Okay?
Right. But so it sends it out to router A, and then router A doesn't have anything, and router A is F, and then it sends a broadcast to PC3, and then router A sends a response back to PC1.
Right.
And then it puts the destination address of router A into its MAC table.
Yep.
And after it puts that in there, then it sends an ICM ping back to router A.
Yep.
And then now we have to find the source MAC address of, and we don't have the source MAC address. Then after if router A checks to see if PC1 is in the table for router A.
Right.
So the table for router A doesn't have anything in there for the source MAC address, but it updates the destination MAC address for the PC1 of 8.8268.
Right. Tell you what, can we take a break for about 5 minutes? Let me just grab a cup of coffee because my throat is getting really scratchy, okay?
Okay.
All right, I'll be right back.
I'll be right back. Hey, Jim? Jim?
Okay, here I come, Sam.
All right.
Yeah, I've been talking way too much today.
Yeah.
Before I got on the phone with you, I guess I had been talking already for 2 hours with another customer. Okay, so let's see. Sends out the N7. Hmm. Wow. Okay.
So once PC3 receives it, it updates the ARP table with the source IP, with the source MAC address,
Mm-hmm.
and then it sends the response back to Vital A and the source address, and then it will be the
Right.
And then can we also do something with the table entries for this?
Oh yeah, I can put in all the table entries in this. Yes. Okay. In fact,
192, 168. D is 192 and 68.10 11 D101 11 8260 192.168 20.15
Okay.
So first we send out the ASEAN ping from PC1 to PC3, but it's not inside the local network.
Yeah,
And
but
then
I'm not done yet, Sam. I still have to write all this up. Okay, I'm almost there.
okay.
Do you want me to finish, or do you want to go back and review some of this first?
Can you finish?
Okay, very good. Okay. Okay. help if I could spell right. Okay. Okay. Okay, PC1, no. Okay, there we go. Let's go through it.
Okay.
Would it be better if I sent you these files so you could print them out and read them rather than looking at my screen?
Yeah, I will have it, but it would be better like if I'm able to print them out too.
Okay, hold on. Let me just save them first. Save. Okay, Sam, give it a minute, and it should be in your Sam Google Drive.
Oh, wait. So it switch off demonstration notes and then switch off demonstration table entries example 2, notes
It says
example 2.
2. Yeah, example 2. Okay, that's what you want to look at.
Okay. 1 second. I'll be right back.
Good.
I got it.
Good.
And Jen,
Yes.
now can we go over this?
Yep. Okay, so why don't you read through it, okay? And
Like PC1 sends a ping to PC3. It prepares an ICMP ping packet with the source address 10.1 and destination address 20.13. PC1 L3 sees that the packet's destination is not the local network.
Sam,
196.
do you know what I mean by PC1 L3?
What do you mean by L3?
I mean layer 3. This is PC1. and it's layer 3, its network layer is doing this, okay?
Right. It's layer 3.
So I'm just trying to be clear what layers do what tasks, okay? So that's what I mean by L3, okay?
Okay.
Okay, go ahead. I'm sorry.
PC1 layer 3 sees that the packet destination is not the local network 192.168.10. Are you putting 0 on there?
Yes, because remember, that's the network ID, right?
That's network ID. That's
Right.
0 is the first portion.
So what's happening is that PC1 knows that its network ID is 10.0, but it sees that this packet, this ping, is destined for 20.0 and says, oh, this is not my local network. This is another network, so I need to send this to my nearest gateway router, which happens to be at IP address 10.1.
Right.
Okay, go ahead.
PC3 layer 3 looks at the. I must forward the packet to the nearest gateway router A, Internet Protocol 10.1. PC1 layer 3 looks at the ARP table for the MAC address of router A 10.1. PC1 layer 3 does not find an ARP entry for router A and then prepares an ARP request for the MAC address for router A, placing all MFF into the destination MAC address, indicating a broadcast. PC1 layer 2 takes the ARP request from above and sends a frame containing the ARP request packet and the source MAC address and destination F. PC1 layer 1 sends the Ethernet frame onto the wire. And then router A layer 2 receives the frame and sees that the destination MAC address is a broadcast address and contains an ARP request packet which it passes up to the network layer. Router A layer 3 opens the ARP request and sees that the destination IP address is its own address for port FA00. Router A layer 3 prepares an ARP reply, placing the source MAC address D.1.101 and a destination MAC address .8268. .8268 and the source IP 10.1 and the destination IP 10.11. And router A sends the ARP reply back to PC1. And then PC1 receives the ARP reply and updates its ARP table with the information from the router A, like 10.1 and 101. PC1 now has the MAC address for router A and retrieves the ping packet from the earlier and completes the packet frame with router A's MAC address for the destination MAC address .101. PC1 sends the ping packet out. And then router A receives the ping packet and realizes that the ultimate destination is to PC3 at 192.168.20.13. Router A looks up the destination IP address in the routing table and finds the network 192.168.20.0 is directly connected to router A. Router A then attempts to forward the ping packet to PC3, but after looking at its ARP table, realizes that it does not have the MAC address for PC3. Router A temporarily stores the ping packet and prepares an ARP request for PC3.
Okay.
And then router A sends the ARP request to PC3 with a destination MAC address of all apps, indicating that it does not know the MAC address of this ARP request. It is a broadcast. PC3 receives the ARP request and updates its ARP table with the information from router A. From router A, G.102, and prepares a reply with this MAC address and places it into the reply's source MAC address. PC3 sends the ARP reply out, and then router A receives the ARP reply and updates its ARP table to include the information from PC3. Router A then retrieves the ping packet it has buffered oil, updates the packet with the MAC address for PC3, and sends the ping packet out through port FA01. And then PC3 receives the ping packet, examines it, and prepares a response. PC3 sends the response to router A with the ultimate destination PC1. Router A receives the ping packet, has all the necessary information to forward the packet to PC1 through port FA00, and then router A sends the packet. And then PC1 receives the packet, the ping is successful.
There you go. Does that make sense?
So for this one, first it does an ICM, it does a ping to PC3 from the source address 10.11 IP and MAC number .8268 to the destination .13 to .8462, but it doesn't find it in the local network. Then it sends the packet encapsulated and sends the packet to router A with the destination at MAC address of all apps, because there's no destination in the table. Then router A sends a broadcast to PC3, and then router A sends it to PC1. And then they put the destination address of PC1 in the drop table.
Mm-hmm.
And then PC1 puts in the destination MAC address of router A. And then after that, then PC1 sends the request to then router A sends the request to PC3.
Say that again.
So does our router A send the request to PC3?
Yes.
The router A sends the request to PC3, but it has a source address of 10.1. It checks to see if the source address is in the table, and it puts it in there. And then the router sends the request to PC3, and then PC3 examines it to see if the destination MAC address is in the table. If not, then it puts it in the destination of .v102 with 20.1. And then it checks to see if the source MAC address is in the table.
Mm-hmm.
And if not in there, then it has to update in the PC3.
Right.
To .8462. Before sending the response. And then it sends the response back to.
It sends the ping, doesn't it? It sends the ping on to PC3, right?
Yeah, it sends the ping to PC3.
Right, there you go.
doesn't. Some of it is not making some sense to me.
Okay. Hold on. Which number is not making sense? Or where does it start not to make sense?
How does it go from the source to the destination? How it gets to 20.1 and how you got 10.1?
What number are you looking at, Sam? What step number are you looking at? Sam?
What?
What step number are you looking at that where it starts to get confusing?
It's getting confusing where it goes from 10.1.
No, Sam, what step number does it start getting confusing at? I don't know where you're at, okay? See the step numbers over here? You see the step numbers on the left-hand side?
Yeah.
What step number are you getting confused at?
Number 15.
15. Okay. All right. Good. Super. So, router A receives the ping packet from PC1. And as it looks at this packet, it realizes that the ultimate destination for the ping packet is 20.13, right?
Right.
And the source is 10.11, correct?
Correct.
Okay. So now router A has to forward this on to 20.13. So the first thing it's got to do is it's got to say, okay, well, based on the routing table, where am I going to send this ping packet? So it looks at the routing table and it says, hey, I have an entry here for the network 192.168.20. And not only do I have an entry in the routing table, but I see that this network is directly connected to me. It's not some far off network. It's directly connected. Okay?
Right.
So at this point, it doesn't need to forward the packet to another router. It needs to forward the packet directly to PC3. Okay?
Right.
So at this point, it now prepares, it's modifying the ping packet so that the source continues to read 10.1, and the destination IP address is going to be what?
After 10.1?
No, what's the destination IP address for this thing going to be?
It's 20.13.
20.13, right. So it's got that. Now it goes looking at the ARP table to see, hey, do I have a MAC address for 20.13? And what does it find out?
It does not have it.
It doesn't have it, okay? So before it can forward this ping packet along to PC3, what does it have to do? What does router A have to do?
Router A has to send a broadcast.
Well, let's be a little more clear, okay? Router A has to do an ARP request to PC3 to find out PC3's MAC address, right?
Right.
Okay. So now router A prepares, okay, an ARP request. And in that ARP request, ultimately that ARP request is going where? Who do we want to respond to our ARP request?
PC3.
PC3. So router A prepares the ARP request. What is in the destination, or I'm sorry, what is in the source IP address, okay, of the ARP request?
In PC3?
No. In router A, what is the source IP?
It's
address.
It's .c102.
No. Listen, okay. What is the source IP, not MAC, source IP address? Who's making the request, Sam?
Router A.
Right. Okay. So it's router A's IP address, right? But
Right.
which address? Router A has 2 IP addresses, correct?
Correct.
All right. So which address? We're going from router A to PC3. So what is the source IP address in this ARP request?
It's 192.168.20.
Dot
0, but it's .0 for the network portion, but it's .1.
No. It has to be .1. Okay? It has to be
Right.
.1. So the source IP address is 192.168.20.1, right?
Right.
And what is the source MAC address for this ARP request?
It's D102.
D102, correct. Now, we know the MAC address, we know the IP address for PC3. And router A knows that that's ultimately where we're going, is 20.13, right?
Right.
But does router A know what PC3's MAC address is?
No.
No, it does not. So what is router A going to put in for the destination MAC address?
All F's.
All F's, which indicate 2 things, okay? First, it doesn't know the MAC address, okay?
Right.
2, anyone who sees all F's in the MAC address knows that this is a broadcast, okay?
Right.
So this is going to be, the ARP request is literally a broadcast, okay? Now, there's only one system out there, namely PC3, that's going to see this thing. But that's the information it puts in. So it creates the ARP request with a source IP of 20.1 and a source MAC of D102, a destination IP of 20.13, and a destination MAC of all F's. And it sends, and in the meantime, what has it done with that ping packet it was trying to send out?
It tries to send it back.
Well, what it's done is it's temporarily set it to the side. Okay? It's set it to the side so that it buffered it so that it will come back to it and work on it when it's done. Okay? When it gets the updated MAC information, then it will attempt to do the ping. Okay?
Right.
So anyway, router A sends the ARP request out to PC3. Okay? So we're down at step number 19 now. Okay? So PC3 gets the ARP request, and it looks inside, and it updates its ARP table with the information from router A. Specifically, what information is it going to update?
For router A, it's going to update. It's going to update the.
It's going to put this information in right over here.
The source or destination.
No. Look at it. PC3 just received this ARP request. Okay.
Right.
And if we look at that ARP request, we will see that in the source field, okay, the source IP is 20.1 and the source MAC is D102. So that's what it's going to put in the table.
Right.
Okay.
That's the source, and the destination is 192. You see that the source is in there, then it updates the destination in the MAC table.
Right. Correct. Okay.
Wait, can you put the steps on there for the table? For the table entries.
Oh, okay. Yeah. So okay, updates the table to include the, okay, so that is step number 21. There you go. Okay.
Can you include the steps for the lateral A?
Yep. Hold on. Okay, and okay, there we go. Okay.
Yeah, how about for dot D102?
Yes, this happens at initialization. It happens before we start going through our steps. Okay. This happens automatically. Okay. As soon as the router starts up, it sees that its IP address and the MAC address. It does that right off from the very start. Okay.
Right, but
That's what okay, I'll tell you what. Let's call it, make it clearer. Let's call it step 0.
Okay.
Does that make more sense?
That makes more sense. And then okay. Give me one. And can we do something a little similar, like change the port numbers around?
The port numbers? I don't think that's going to help you much, Sam.
Yeah. Not the port number. Instead of .11, how about dot?
Oh, different IP addresses?
Yeah, with different IP addresses.
Okay, that means I'm going to have to reconfigure this whole thing. Okay. Can we do that the next time we meet? Because I'm going to need some time to do that.
Yeah, and can we move I know we went over switching and routing. Can we also go over a day in the life? Someone you said we go over
Sure. Yes, we can definitely do that. Okay. Do you want me to put together like a similar type of situation here for the day in the life?
Yeah, a day in the life and other things we went over, like similar scenario problems. Yeah.
Okay, very good. Very good. Then I will prepare that. When's the next time you and I are getting together?
I'll text you tomorrow morning. I'll.
Okay.
Is that okay? I'll text you tomorrow morning.
Yeah, just be aware that tomorrow afternoon and tomorrow night I'm going to be tied up. And then I'm going to be working. I've got an appointment Monday morning, but I will be available Monday afternoon.
Okay.
Okay?
Yeah, I know. Can we look about also DHCP? I studied the DHCP step, but can we go over the DHCP too?
HTTP?
DHCP.
Oh, DHCP. Yeah. Dynamic Host Configuration Protocol. Yes, most definitely.
Yeah,
Okay.
can we go? Yeah, I know the that, but can we? Okay, for chapter 5, can we go over all the other stuff? I know we went over this and this. I know we went over with the router and the switch. Can we also go over, like, I know we did day in the life where it's not clear to understand. We can go over that.
Okay. All right. Very good.
All right.
Okay, Sam. So I'll wait for your text tomorrow morning. Okay.
Yeah. Can you also resend me the table with the steps on it and the demonstrations with the switch and without the switch?
Okay. Well, without the switch, you already have everything with the switch. Okay.
Yeah, but yeah, I might need the picture.
I'm gonna resave these here. File, save, file, save. So you should now have updated copies for example number 2. Okay.
Okay. And then can you also send, like, we did the packet tracer and we did where we are sending it back and forth.
Right.
Can you also send me the picture that you have?
What? I'm confused. What picture are we talking about?
The one with the router and the one that we did with the switch the other day. And the one with the router and the one with the switch that we did the other day. I have the step for it, but
Oh, you just want the diagram?
yeah, can I also have the diagram?
Sure. Yeah. Okay. All right. Here, let me do that right now. Okay. So we're going to take this, and 1 second. I'm going to send you 2 diagrams. So we got snipping tool here. Okay, so that's the first one, and let's open up a Word document. All right, 1 second. So Sam, is this what you want?
Give me 1 second. Yeah, I want like example 1 here.
Well, that's what we have here.
Yeah, I'm on example 2 in a separate file. Is that, yeah.
In a separate file?
Yeah.
Okay. There you go.
All right.
So if we look, there's example 1 and example 2. Okay?
Okay, give me 1 second.
Okay. I'm going to stop the recording now.
Okay.